Alright, so this video is covering the notes, not the page 4 notes in the packet, but these slide notes covering naming acids and then a little bit about bases as well. It's a little more detailed than what you saw on page 4. It's the same basic breakdown with a little bit more practice, and because all of this practice is virtual, it's going to be real easy for us to fill it in, and you'll notice that on a lot of these practice slides as well as on some of these notes slides I have put some extra stuff in the margins so that you can kind of see and look at that while you're working and editing these slides in order to get these examples filled in. And the reason I wanted to do it this way, even though it does technically have more work for you to do and more examples, this is every single acid you're ever going to have to name in my class here. So after we're done with these notes and we have this filled out pretty quickly and simply using the digital tools that we have, since we can copy and paste stuff from elsewhere in the document, you're going to have every single answer for every single acid name that I can ever possibly ask you. And probably 90% of the base formulas once we get done with these. So it's well worth your time and effort if you'd rather take the quick way out for the notes. Everything you should need is already technically written here on our slides, and you can use this to help supplement the notes that are written for you in the packet. And you can just do the page 4 practice problems if you want and move on, but this is in case you need some extra help. So for these first few slides I am going to present. So we're talking about writing and naming acids and bases. And so I have a short little synopsis of acid formulas and names, and then we'll dig into each of the special types. So the short version of how to write an acid formula is they always start with H's, and then there's some other element or polyatomic ion that follow them. And all we've got to do to write the formula is cross-drop reduce the charges of that H and that other piece. So really the first step is going to be interpreting the name of this acid to figure out, well, if this is hydro, and of course that's not very clear, but if that's hydrobromic acid, long story short, we're going to have a bromine here with a -1 charge, and all we're going to have to do is cross-drop reduce that together in order to make HBr. But we'd have to be able to understand why this name hydrobromic acid means that that is a bromine there. Hopefully it's a little bit obvious, but yeah, we're going to use the name, find the pieces, cross-drop reduce. That's all there is to writing formulas. And with names, there's 3 different types of names, and so this is why it's so important to understand the names. It's because this is what gives you the formulas as well, depending on what type of name it is. So the first type is the simplest, shorter type. It's what we call binary. Generally that means that there's only one element with that H at the beginning, and the shortcut, or kind of the saying, add hydro if there's no O. Hydro is going to be at the beginning of these names if there's no O in the formula. So that's our first type. Those do end with ic acid, just like our second type, which has a polyatomic in it that ends in 8. So you can call this a poly-8 acid because it might have something like sulfate in it. And if it does, that would be H2SO4, of course, practicing writing those formulas. But that is sulfuric acid. There's no hydro at the beginning of it because we do have some O's here. But we just take the polyatomic name sulfate and add ic acid instead of the 8 part. And then just like we can have sulfate, we can have sulfite, which is very similar, just a different number of oxygens. So we've still got oxygen in here, so we're not using hydro at the beginning when we have a polyatomic. It's just sulfur for sulfite here. And then when it's the ite version of the polyatomic, we change that ending to be us. So this is sulfurous acid. So we have three main types. You can see them broken up here. It really comes back to what is that thing that's in them. And trying to look back at the name of the polyatomic or the name of the element. That's going to be the root, the blank space here in this name, kind of fill in the blank section here. And then we just change that name slightly depending on what that thing is specifically. So let's get into the details of each of these types separately so that we can really focus on how these names are all similar to the other names and formulas around it. And this is actually where I am going to back out of my fancy presenter view, and I am going to zoom in a little bit closer just so you can read stuff when I'm looking at it. So I'm going to start with our names and doing names all the way down, or at least a few of them. I'll finish them out, but we'll just do the few that I can see here. So these names for these acids are going to be based off of this ion, so F-1, and actually we could probably start with a few formulas since those are simpler. Formulas start with H's and then they end with whatever that ion is. And here when our formula, or our ion, is a -1, we're going to be cross-dropping, reducing this +1 from the H with the -1 from the F. So when it's +1 and -1, we don't even have to ask ourselves what that little number is going to be. It's just going to be HF. And that's going to be the same thing with these other -1 ions. Just go with that. Even all the way down to astatine, HAT. All of these are just going to be one of one and one of the other because it's a +1 -1 in our formula. Once we start getting down to oxygen, that H, which does have a +1 charge, is going to be crossing with oxygen's -2. You don't have to write this part out. I'm just doing it so you can see these ions just like we normally do. And so once these do cross-drop reduce, the 1's going to be crossing over onto the O and disappearing, and then this 2 is going to be coming over into the middle and becoming a subscript. And that formula should look kind of familiar to you. H2O. So we're going to have the same thing happen with this sulfide ion. It's just going to have an S instead of the O. So my suggestion is copy and paste that, and then delete the O and make it an S. And then I'm going to do the same thing here and make it an SE, and then make it a TE. Now, quick little word about some kind of digital formatting. If I had copied just the H2 and pasted that, then when I started trying to type, everything I was typing would be a subscript. And so even though I didn't want to keep that next letter, by copying it, it kind of copies that formatting there so that I can delete the letter and just input whatever other letters I want, and it'll stay the same formatting as that. So I'm going to go ahead and do just a couple more. I know this is going to be H3N. I can come and control comma that. I'm not sure why that's not centered anymore. I like it centered. But now I can copy and paste that. Also, if yours is giving you a weird spacing issue there, you might be copying some of this extra space, which also includes this weird formatting for a carriage return. So if you copy and paste that, then you're going to mess up this table. It's going to go way all over the place. So when you're copying and pasting, if you're careful to just copy the letters and not anything more, then you won't end up with that weird spacing issue. So I'm going to stop there. We'll come back and finish these out. We've gotten a few formulas here to use as examples, and so here we can see a little bit better where some of these naming rules come from. We're going to add hydro at the beginning of each of these names because there's no O's in our formula. It's just binary, just H and F. And then the root name that fills in this spot here is going to come from our ion name, which is really just a version of the element name with "ide" on the end. But that kind of helps us see. We're going to be changing that "ide" ending to be an "ic" ending. So here, with all of these that have this "ide," I can kind of highlight that part yellow. This is going to turn into hydrofluor, and then "ic," and the word acid. So hydrofluoric acid. Now, especially since I'm editing this digitally, I know that all of this is going to be the same. Hydro something, ic, acid. And it's trying to correct me. It thinks it knows what I'm doing, and it doesn't. So it has a problem with what I've typed here, but I'm going to copy and paste this all the way down my page. Hydroic acid, which is not the correct answer for any of these names, but it has everything that I need except for that root element name. So this next one, I'm going to do the same thing. Take everything but the "ide," the chlor part, and put that over here, in between the hydro and the "ic" acid. So hydrochloric acid is what HCl is. And then bromide turns into bromic, hydrobromic acid, hydroiodic acid, hydroastatic acid. And some of you can probably type fast enough that this is not difficult to write out all on your own. But sometimes copying and pasting might just be easier and helps you kind of see this pattern. Where we break the pattern a little bit is when we get to oxygen and sulfur. Hydroxidic acid has that double O in the middle, so we do tend to drop an O. And then it keeps a little bit more of that there to make it oxidic instead of like hydroxic acid. So that is our, put that back. Hydroxidic acid. And then same with sulfur or sulfide, is it kind of is okay-ish if you write hydrosulfic acid. You're following all the rules there, but for whatever reason, it just sounds better, or the normal name for this acid is hydrosulfuric acid. So we keep just an extra syllable there on this name here. We run into a couple more weird ones as we get into some of the elements that we don't use very often. Hydroselenic acid, hydrotelluric acid, hydronitric acid is a pretty normal one. Hydrophosphoric acid, adding an extra syllable there. Hydroarsenic acid, and then hydrocarbonic acid there instead of hydrocarbic acid. And yeah, just a couple more. This one follows the normal kind of rules. We're taking the silis for silicone, but it turns into hydrosilicic acid. I believe that C, that first C at least, is pronounced as an S. You're not going to see this very much. It's really unstable, and I even Googled this to try and make sure I was spelling it correctly, and I am. It is a thing. It doesn't exist very often, but it's kind of cool stuff when I was looking at it. So if you're interested in some cool, weird chemistry stuff, maybe look at this stuff, which would be H4Si. We cross-drop reduce that -4 charge with the +4. And I'm going to use that to do my carbide one. And then you see here at the bottom we have cyanide, and we are going to call that hydrocyanic acid. This is just going to be HCN. It is the only acid on this page that is not binary. We still include it here though, because like the rest of these ions, its ion does end in "ide," which does mean that it does get named the same way as the rest of these. And as we look at the polyatomic ions on these next couple of pages, and I do have a list of all of the polyatomics here over to the side, you'll notice it's the only one that ends in "ide" that we can make an acid out of. So it doesn't end in "ate," it doesn't end in "ite," it doesn't belong here, it doesn't have oxygens like these are. These are called oxyacids. So it's a little bit weird, it's a little bit special, but it is right here in our list, hydrocyanic acid. So I know those were a lot, and hopefully you got those all filled in there, but this is probably half of the acids you will ever possibly be asked to name here. So they all start with hydro, root element name, and then ic acid, and we just cross-drop reduce those formulas together. So everything is basically the same here, except no hydro at the beginning. So we're going to take each of these ion names, and those are going to be the start of their acid name. So I copied and pasted too much. I'm going to actually copy and paste the names of those ions, and then on each and every one of these, we're just going to change the "ate" part of that to "ic acid." If it's acetate in that compound, in that acid, then it's going to be acetic acid. So same thing here, carbonic acid, chloric acid, chromic acid, dichromic acid, and just keeping going all the way down the page. We do get to our phosphorus and sulfur at the bottom, where we did add an extra syllable last time. Instead of calling it instead of calling it phosphic, we called it phosphoric. And instead of calling it sulfic, we called it sulfuric. So these were the two that had that extra syllable on the last page, and they are going to have that same kind of extra syllable here. Not going to count off if you don't remember that. As long as you follow this general rule here, we're going to be good. And the acid formula is mostly going to be H's at the beginnings of these ions. And because these ions are a little more complicated, I'm going to copy and paste those over here. And just like before, the beginning of our formula is going to be an H. So at the very least, I'm going to be adding an H to the beginning of each of these formulas. And if this is a -1 charge, then that's all I have to do, is put the H at the beginning to balance out the -1 charge with that positive charge, and delete that charge from the end. So that's probably how I would start here, is just doing that, going through the motions, even if I'm not thinking too much about it. I'm just going to find all of the simple acids where I'm not actually going to have to change the formula much. And now I'm going to go back to anything that has a charge greater than -1 and add that many H's to the beginning. So because this was a -2 charge, I'm going to be crossing that -2 over onto the H. I'm going to use my control comma as my shortcut. So that's kind of showing my cross drop reduce there. And then what I'm going to do to be efficient is copy that H2 and look for any other ions that have a -2 charge. And that way I can add those there at the beginning, get rid of that charge. And I've got my formula written out correctly and quickly as well. So the last one I've got to do is this phosphoric acid, just making sure that that is a 3 instead of a 2. So this is all of those names and formulas, just making sure that as soon as we start to see oxygens in our formula, we drop the hydro that was at the beginning of the name, and we just make it ic acid. Now, I actually do want you to go ahead and either cross out, delete, or maybe like just delete from here or something. This hydrogen carbonate is a polyatomic that does exist and is used lots in chemistry, but we're not going to really use it much in acids. If you look at the formula, you might start to kind of see why. This kind of looks a little weird here. We wouldn't actually write out this hydrogen carbonic acid with HHCO3. We would probably change that to H2CO3 since there's two H's there. And this formula here is actually identical to this formula here, which is just plain old carbonic acid. So, yeah, we have that kind of partially ionized acid that is included down here as hydrogen carbonate, but once that forms an acid, it's forming carbonic acid. So we're never, ever going to call it hydrogen carbonic acid. So my suggestion, because that's not kind of its own separate ion or its own separate acid, is just cross that out or delete it. Like I said, this single strike through in the formatting for your text is a great handy way to just say, hey, you won't have to worry about it, but you've got it there just in case you're curious why it got crossed out or if you'd done something wrong. So we've got one last set of acids left to write names and formulas of, and this is the same deal as the last one. We have some special polyatomics from our list. There's just not very many of them that end in "ite." So the only thing that's going to be different about this when we're naming them is that these "ite" endings change to "us." And then we add the word acid just like before. And if I copy and paste, I can change "ite" to "us acid" real quick and simple. Sulfus acid sounds weird. Remember, we add that extra syllable to make it sound a little bit better. So sulfurous acid is its name. Copy and paste in these acid formulas over here just like the last one. If it's -1, when that crosses over, we don't ever write the 1 here. So we can just put an H at the beginning, get rid of this charge. H at the beginning, get rid of the charge. The only one we actually have to do a little more on is when we have that 2 as our charge. That 2 crosses over and becomes our subscript. So that is the last acid formula you should have to come up with on your own. Every single one of these are fair game on tests or quizzes, but there's literally no other elements that can bond with H's. And we've got everything that is possibly negatively charged over here that could be attracted to that positive H. We've got every single polyatomic analyzed, whether it's the cyanide down here or the rest of these here. You know what it's going to be called. So we can always come back to these slides. Now, bases shouldn't be that difficult, and like I said before, these don't cover quite every single base that could exist, but I covered most of them, the big ones. And so I am going to review naming these bases. Not sure why that hadn't shown up. Sorry about that. And it is a lot simpler process than our acids. So hopefully you can stick with it. I'm going to present just to make this a little bigger for a couple of slides. There's only one base that doesn't follow these rules, and that's ammonia, NH3. We've talked about kind of needing to be familiar with that for a while now. So if you need to write it down in your packet, do it, but you got to know what ammonia is. And our base formulas, at least the simple bases that aren't like ammonia, all end in OH. So kind of like with the acids, we're just trying to figure out what's the thing before the OH, what is its charge, and then we're going to cross-drop reduce that charge onto the OH. So you can see here we're going to form either a simple something OH if that something's charge over here is a +1, then that's all we got to do is stick it with an OH. If that charge is like a +2, 3, 4, anything greater than a 1, when that crosses over onto our OH, we have to put it in parentheses. So this is only going to be for 2s, 3s, 4s, etc. If it's a 1, then we should just write it out straight forward, just something OH. And the name of OH is hydroxide. So the names of these bases should be real simple. It's that first thing, whatever its name is, and then the word hydroxide. and that's it. The only way this is going to get more complicated is if we have a transition metal in it, but even then, the only other thing it adds is the charge of the transition metal goes in the middle of the name. And when we were stuck trying to find out what these charges were, I know you didn't like finding Roman numerals in the past, but in bases, it's really easy because that Roman numeral, that charge of the metal, is going to be sitting there right at the end of our formula, like we just kind of discussed right over here. Whatever that charge is going to be sitting at the end of your bases formula. So you can use that to figure out what Roman numeral is going to be in your name. Real quick, real easy. So this first slide is all of our normal bases. I almost said acids. So looking at that periodic table, these are the red charges that we know are always going to be these charges. I just listed out every single element on the periodic table that's positively charged, so it'll connect with that negative OH, and that has a set charge. So if we start, doesn't really matter, names or formulas, but remember how this name of our base is going to start with the name of whatever that ion is. I've got all the names here. Let's use our resources wisely and copy and paste these over here. And then literally the only other thing we need to add to that name is the word hydroxide. So yeah, I'm going to add that to the end of my first one, and then I'm going to copy and paste all the way down. And I'm done with all of my names. I don't even know how many of them that is, but that's their name. It's just the first thing and then the last thing. Now, let's actually see what these bases look like. When we put these together, remember what we saw before? We're cross-dropping, reducing the charge from our ion onto the OH. So if that is a +1 charge, then I just need one OH there, and it's just LiOH. So I'm actually going to copy and paste the rest of these into this space. And if it's a +1, I'm just going to add an OH at the end. In fact, I'm going to copy and paste the OH so the formatting is correct. And then when I get to the +2s, that charge is going to be crossing over, and this is going to be the first time I'm going to need to put parentheses around my element, or my OH, and then a 2 on the outside, making that a subscript. And then copying that, I'm going to put that at the end of all of my +2 formulas, including, I almost forgot down here, I had a couple more +1s where all I need to do is add an OH at the end, copy it and paste in a normal OH so that my formatting is correct. Doing something very similar to this, but when I have a +3 charge, this number at the end is going to be a 3. And so that's the last of my formulas, at least for the normal old, plain old bases. Just one thing of each, and then when we do need more than one, we put that OH in parentheses. Almost done. This last set of bases are bases that have these green transition metals in them, and I made a little side note here. This is the only slide that doesn't 100% cover things, because these elements that I've chosen can have multiple charges, and if you Google like what are the possible charges of titanium or chromium, you'll notice there's a lot. So I couldn't possibly show you all of them, and you shouldn't really need all of them written out. They're all going to be functionally the same as what we're writing here. If the charge is slightly different, the name and formula will be slightly different, but hopefully you can make that change. So we're going to take these names as our starting point over and over again. The only thing different about these is that they need those Roman numerals in the middle. And so I'm going to copy and paste that Roman kind of parentheses hydroxide all the way down my page, just to set up the expectation that I'm going to fill those in with some kind of Roman numerals. I've got these numbers off to the side so I can kind of get help with my Roman numerals, but it really is just whatever this charge is going to come into the middle and be our Roman numeral. So 2 lines for 2, 3 lines for 3, IV is 4, 2 lines for 2, 3 lines for 3, 1 for 1. I'm just doing a capital I here. I know there's a couple of different ways that you can make these markings. Do whatever works for you. Do a couple of the weird ones. VI is 6, V is 5. I think we've done a few of each at this point. 2, might as well just finish it out. 3, 1, and 2. All right. And then our formula is going to start with these elements and end with OH, just like what we had seen in our last slide. In fact, everything about this is this formula writing is the same as our last slide, especially since you're already given these specific charges here. So I'm just going through. I got all my 1s taken care of with the +1 charge. Now I'm going to take care of my 2s. Coming in, using control comma, which is a nice shortcut, but it still takes a minute. So much quicker after you do 1 to copy that, making sure that we're only copying the letters we want. Don't keep going past it, because that extra little space is going to mess up our spacing. And then I'm just looking for anything else that's a +2, getting rid of that charge and adding the OH2 to the end. And you can use that because it has the parentheses there as your structure for all of the other ones. Make it a 3, copy and paste it into each of these 3s, and then 4, make it a 4, only one other 4, and then we've got a 6 and a 5 here. So you can see all of the different variations of these names and formulas and practice putting them together. And even if you do on a test or a quiz, it asks you what is the formula for titanium 4 hydroxide. If you only see the difference is that this middle number is a 4, meaning an IV, instead, then you know that matches up with a 4, and the only difference about your formula is that there would be a 4 there at the end. So I think these are the most common individual elements and ions out of all of those transition metals that you'll see. So hopefully you'll have an example of each kind of to work with, and there might be some little changes in what the actual charge is of that element, but that's going to cause a very small difference or change in your name or formula. And hopefully with these diagrammed already, that should make your life a little bit easier. So these are our bases. I'm going to click back and forth over those for a moment. I know you can go back and look at them. And then these are our 3 different acids, all filled in and ready for you to use as a reference on any test or quiz that you come across, and for as long as you need them. So I hope this helped. I know it was long, but it's got you a lot of answers for tests and quizzes. Let me know if you have any questions I can help with. Bye.